Hello, welcome to Flip. So today we are on periodic trends, and really it's just using the periodic table to tell us more about our elements and their reactions. Okay, so the periodic table, which I'll show in a minute, is really just to classify elements according to their physical and chemical properties. Okay, it's also to show trends, and is useful to compare between elements. Okay, it's for these three purposes. Okay, before we delve into the periodic table, let me just give you a quick recap regarding the element symbol. So this is the element symbol. For example, this is our sodium. Okay, on the top of it is called the proton number. Below it's called the relative atomic mass, which is actually just proton plus neutron. Okay, whereas for the top one, it's really just proton only. Okay, and hence you can see that the bottom number is always greater than the top number, because the bottom number includes the proton and the neutron, whereas the top number only includes the proton. Okay, some textbooks and some teachers may just flip it around, but we are sticking to the O-level syllabus, which is the bottom number is the bigger one, which is the atomic mass, and the top number is the smaller one, which is the proton number. Okay, let me just show you the periodic table right now. So this is the periodic table we will be using, in the whole O-level syllabus, You can see that maybe we just take an example of iron, Fe, you can see that the top number, it's 26. The bottom number is 56, So the bottom number is bigger than the top number, Some, like I said, will just flip it around, but this is the O-level syllabus, so we'll just stick with it. Okay, there are different things to unpack here, You can see that, that there are different colors, So my intention is to use different colors to explain one concept, which should make it easier for you. Okay, you can see that this is a periodic table, As the proton number increase from left to right, I'm talking about this way, So this is left, this is right, So as I move along here, this is from left to right, Proton number increases. For example, let's take a look here. This is 3 proton, 4 proton, 5, 6, 7, 8, 9, 10. Then again 11, 12, 13, 14, 15, 16, etc. So it just increases from left to right. And also when proton number increases, mass number increases as well. Let's take a look at this one again. Lithium, 7 to 9 to 11 to 12 to 14, etc. So it's also increasing from left to right. Hopefully that's clear for the red portion. So next one, we will move on to what's the name of the vertical and horizontal rows and columns. So this one, it's downwards. This is called group. Means it's vertical. Vertical means like standing straight. Standing tall and straight. This is called group. And we like to call it down the group when we move on from helium to neon to argon, for example. Fluorine to chlorine to bromine, for example. This is moving down a group, down a group, down a group. So this is group 1, group 2, 3, 4, 5, 6, 7, and 0. These are called groups when they move downward like that. This is called a group. On the other hand, this is called a period. Period moves from it's a horizontal direction, which means this is period 1. This is period 2, this is period 3, etc. So horizontal, will be called period. That means it's moving from this direction, left to right or right to left. Whereas group is top to down or bottom to up. That's the difference between groups and periods. Now let's move on to the pink portion, which is talking about metals on the left, non-metals on the right. So what does this mean? So you can see that I've drew a line here. This is like a ladder, which separates metals from non-metals. So everything from on the left-hand side of the line here, so this whole portion here are all metals, whereas this portion here are non-metals. So very clearly, for example, fluorine is a non-metal because it's on the right-hand side of the zigzag line. Another example would be calcium. It's on the left-hand side of the zigzag line, so it's a metal. What about things like boron, aluminium, silicon, germanium? Okay, they sort of sit on a line. Do you agree? Okay, that means the line touches them. Okay, touches the box. These are called metalloids. Okay, metalloids. Okay, you can see here. That means they have both metal and non-metal properties. Okay, that means you can say that it's neither a metal or non-metal because they have both properties of metal and non-metal. Okay, we will not be touching much on this in the O-level syllabus. It's just something to know. Okay, you just have to know the word metalloid, which is something that has both metal and non-metal properties. Okay, so this is the pink portion checked. Okay, finally, this is just a description again of the periodic table. Is that elements arranged by their proton number in ascending order. So what do I mean? So you can see that we start from the first element, hydrogen, okay, to helium. Okay, so it's 1, 2, then we move on to lithium 3, beryllium 4, 5, 6, etc. So you can see that it's a continuous sequence from 1 all the way to for example 116, okay, 112 for example. Okay, below period 3 I would say, okay, it's not tested. Okay, 1, 2, 3, okay, maybe period 4. Okay, below this is really out of the syllabus. Okay, you don't have to know any of them here. You just have to know that they are in which group, for example. Okay, so you just have to know that the proton number is in ascending order, which is from 1 all the way to, for example, 36 in krypton. Okay, hopefully that's clear for the periodic table structure. Let's move on to more details regarding groups and period. Okay, so this is a group. Okay, group really just means that, okay, elements in the same group have similar properties. Means that they have, okay, for example, they react with a certain molecule. Okay, DTG means down the group. Okay, it's something we like to use a lot, okay, in this chapter, okay, because it's easier to call it down the group than from calling it from lithium all the way to francium, am I right? Okay, so yep, again, elements have similar properties down the group, okay, and, okay, sorry, elements have similar properties in the same group, okay, and the properties will change down the group, and it becomes, for example, more and less reactive within certain molecules. For example, in the case of lithium, okay, in the case of lithium, group 1, lithium reacts with water, okay, it reacts, maybe say, it's quite reactive with water, but as it goes down, okay, potassium, it becomes more reactive with water, okay, that's what I mean, okay, it still reacts with water, okay, it's just that how reactive it becomes as we move down, okay, because groups really just means they are the same family. Okay, so this family member reacts with water in a certain way. This family member reacts with water in another way. Okay, just that it's different speeds, different intensity of the reaction. Okay, so that's what we mean by the properties will change down the group. So next one is that certain groups have names. Okay, so for example, group 1, okay, this is group 1, okay, it's called alkali metals. Okay, group 2 are called alkaline earth metals. Okay, this is group 2. Okay, group 7, okay, it's halogens. Okay, group 0 are called noble gases. Okay, this one you have to memorize. Okay, it's just a naming, just memorization. Okay, group 5, okay, here is there's no special name for them. Okay, so you can just call them group 5. Okay, next one is regarding its valence electrons. Okay, let me just change color right here. Okay, so the number of valence electrons is basically the group number. In the case of sodium, okay, let's find sodium here. It's this one, right? Am I right? Sodium has 11 protons. Okay, sodium has 11 protons. You can see from here. So we break it down into it's the way to build up electrons: 2, 8, and 1. Okay, we always begin with 2, then with 8, then the next one will be 8 as well, maximum. Okay, but in this case, 2 plus 8 is already 10, okay, and it's 11 here, so what's remaining is just 1 valence electron. Okay, 1 valence electrons means that it's from group 1. Simple. Okay, so we just look at this one. Next one, let's find magnesium. Okay, magnesium is spelled wrongly here, so sorry about it. There's no M here. Okay, magnesium, it's here. Okay, it's just beside sodium. You can see that it's 12 protons. Okay, because we know that number of proton, it's equal to number of electrons. Okay, so this is the number of protons as well as the number of electrons. Okay, so we know that magnesium has 12 electrons. So according to this, we put 2, then we put 8, now it's total of 10. Okay, we lack a balance of 2. Okay, and this will be 2 valence electrons, and hence now it's group 2. Okay, so it fits in the model correctly as well. Okay, next one is that same group, okay, for example, in the case of group 1, have the same number of valence electrons. Okay, we have established that, okay, for example, sodium, and they lose or gain the same number of electrons, which means they form the same charge. Okay, so in the case of, let's take group 1 for example, lithium will always form lithium plus, sodium will always form sodium plus, and potassium will always form potassium plus. Okay, as we move on along to more chapters, okay, in transition metal, they can have different charges, okay, but this is the general idea for now. Okay, so basically, same group, same charge. Okay, again, same group will give you the same charge. Okay, in the case of group 1 here. Okay, that's because elements gain or lose valence electrons to attain the stable noble gas configuration. Okay, so basically it wants to lose its 1 valence electrons, okay, in the case of sodium, to have the final number as 8. That's what we mean by, okay, a stable noble gas configuration. Okay, just to have 8 at the back. That's what we mean by the stable form. Okay, finally, elements in the same group they form similar compounds, okay, because they perform similar reactions, just at different rates. Okay, for example, I gave you just now I talked about the lithium, okay, reacting with water, and also potassium reacting with water, just that lithium reacts slower than potassium. Okay, similarly is the case of in this case nitrogen and astatine. Okay, so this is, let's take a look, nitrogen here. Okay, nitrogen here, and As is arsenic is here. Okay, so if they are in the same group, they can react with the same compounds. Okay, and they form the same compounds basically. Okay, so for example, in the case of nitrogen, it forms ammonia, NH3. So if N is able to form NH3, As, arsenic, is also able to form AsH3. Okay, because they are same family, that's why they react similarly. Okay, that's what we mean. Just that the rates will be different. The reaction also will be different. Okay, yeah, and that is all for groups. Let's move on to periods. So this is period. Okay, period really just means from, in the case, for example, it's from left to right. Okay, this is period 1, period 2, this is period 3, period 4, etc. Okay, down the group, down the periodic table. Okay, this is period 1. Okay, which just includes hydrogen and helium. Okay, and period 2 is from lithium all the way to neon. Okay, and really period, okay, elements in the same period have same number of shells. So we always like to use sodium, okay, for some reason. Okay, let's find sodium. It's here. It's in period 3 from the periodic table, but let's prove it based on their number of shells. Okay, so sodium, okay, let's do it. Let's break it down. Sodium, okay, 11 protons, 23. This one not very important. We just look at this one. This is the number of proton, which is equals to number of electrons. Okay, so it has 11 electrons. And so when we break it apart, it's 2, 8, and 1. Okay, so now we know that it's group 1. Okay, this one we established that in the previous slide. But now we know that, okay, there are 1, 2, 3. There are 3 shells, okay, and so it's in period 3. Okay, what do I mean by shells? So for example, this is sodium. Okay, this is the first shell. This is the second shell. Okay, and finally this is the third shell. Okay, if you count, there are total of 11 electrons. Okay, this is what we mean by shell. First shell, second shell, and third shell. Okay, and elements change from metal to non-metal from left to right. Okay, we have talked about this with our pink divider. Okay, so everything here it's metal, everything here it's non-metal. Okay, and those between them are called metalloids. Okay, which have both metal and non-metal properties. Okay, and that is all for the introduction to periodic table.